18.6 miles. That is the number we need to start with today. Welcome to our deep dive. In the consumer space, running an HDMI cable to a TV is trivial. But in professional broadcasting, trying to move an uncompressed high-definition video signal across an entire city, so 30 kilometers, is usually where physics just, puts its foot down.
Right. It's the classic distance dilemma because copper wire has high attenuation. The signal just dies from electrical resistance way before it hits that 18-mile mark.
Exactly. Yet the sources for this deep dive focus on a piece of hardware that claims to solve exactly that. We are looking at the Kramer 613RT, which is a transmitter and receiver pair designed for what they call ultra-reach transmission.
And the how here isn't magic, it's the medium.
Right.
Kramer completely ditches copper for this. The system utilizes single-mode fiber optic cable with ST connectors.
Which essentially changes the game from, pushing electricity through a wire to shooting light down a glass tube.
Precisely. The 613T, the transmitter, takes the digital electronic signal and converts it into optical pulses. Then the 613R receiver at the far end catches those flashes of light and decodes them back into digital video. Since light faces significantly less resistance in fiber than electrons do in copper, you get that massive range.
But range is really only half the battle here. The other half is bandwidth. We aren't just sending a basic telegraph signal. We're talking about heavy, data-rich video streams.
Yeah, the spec sheet lists a maximum data rate of 3 gigabits per second. It supports 3G HD SDI.
And for those of you not in a broadcast booth, that refers to the SMPTE 424M standard, which is basically the industry baseline for 1080p video at 60 hertz.
Exactly. But this is where the Kramer unit differentiates itself from just a generic fiber converter. You can't just shine a light for 30 kilometers and expect it to be perfect. Even in fiber, you get dispersion.
Wait, the pulse of light spreads out slightly,
making the on and off signals blurry by the time they arrive.
Which brings us to the really cool proprietary tech mentioned in the documentation. The Kramer equalization and reclocking. And yes, they actually spell reclocking with a capital K.
Marketing spelling aside, the function is absolutely critical. The receiver doesn't just blindly amplify the incoming mess, it actually performs signal hygiene. It rebuilds the digital pulse structure and resynchronizes the entire data stream.
So it's effectively eliminating jitter. Instead of a tired, fuzzy signal limping across the finish line, the receiver reconstructs a fresh, stable signal for your display.
That ensures the video output is indistinguishable from the input, even after that 18-mile journey. And I should mention, since we are talking about shooting data via light, this system uses actual lasers.
But it complies with Laser Class 1 safety standards, specifically IEC 608251.
Right, which means it is safe for the operator under normal usage conditions. You don't need protective eyewear to hook this up.
Now let's talk about the market context. This device is part of the Kramer Tools family. Physically, it's very compact. Financially, well, it is not.
No, it really isn't. The list price hovers around $1,448, and that is a discounted figure.
To a layperson, dropping $1,500 on a video adapter sounds insane. But you have to look at what you're actually buying here.
You're buying reliability. If you're running the Jumbotron feed at a stadium or a campus-wide security network, the cost of a signal dropout is massive. You aren't paying for the plastic box. You are paying for the absolute guarantee that the video arrives.
The vendor data completely backs that up. HDTVSUPPLY lists a 4.7 out of 5-star rating for their service regarding these units. In high-stakes AV integration, supply chain trust is a very legitimate metric. You need to know the gear is genuine and the support actually exists.
It is a professional tool for professional infrastructure. It solves a specific, hard problem distance without compromising the signal quality.
So the Kramer 613RT is essentially the bridge between working in the living room and working across an entire city. It combines fiber optics with that active signal rebuilding to overcome the physical limits of copper.
It really is an elegant solution to a very physical barrier.
But looking at these specs leaves me with a lingering question for you to mull over. This unit is doing some serious heavy lifting just to move 3 gigabits per second. As we rapidly barrel toward 8K video and uncompressed formats where data rates aren't just doubling but exploding exponentially, if we need lasers and complex reclocking just for 1080p today, what does the physical infrastructure of our cities look like 10 years from now? Thanks for joining us on this deep dive.